Hi, now we are going to discuss about a very critical auxiliary system in the pressurized water reactor, that is CVCS. What is CVCS and what it differs from other system? CVCS means chemical and volume control system. It is an auxiliary system in the pressurized water reactor. It is having a very important role in the maintain reactor and coolant quality, control reactor power and ensure safe operation. And what it differs from other system? The main difference with the other system is normal operation system. It is not directly mitigate any accidents. There are four main functions for the CVCS. The first function is it maintains reactor coolant chemistry. How? The controls boron concentration to regulate reactor power because boron absorbs neutrons. Because everybody knows that boron is absorbing neutrons, so it is affecting the reactivity and we can control the reactivity. It also maintains pH and dissolved gas levels to prevent corrosion inside the reactor coolant system. And the next function is it controls reactor coolant volume. First one we studied, it controls reactivity by using with the boron concentration. The next one is controls reactor coolant. It controls reactor coolant volume. How CVC is controlling reactor coolant volume? It adjusts the coolant level to accommodate temperature induced expansion or contraction. It also prevents over pressurization and maintains steady pressure in the primary loop. Okay, and the next function is it purifies reactor coolant. CVCS removes all the impurities, fission products and activated corrosion products to maintain coolant purity, because reactor coolant is having a very important role in the reaction. It also reduces radiation exposure and extends equipment lifespan, because if there is any corrosion or anything happens, it will affect the components lifespan. And the next function is it also provides high pressure injection in the emergency functions. In case of any LOCA, the CVCS can inject coolant into the reactor system. What is LOCA? Because we have to know LOCA because it is a very critical situation in the reactor. LOCA means loss of coolant accident. If there is a severe accident in the which breaks or leak in the reactor coolant system, it causes significant loss of reactor coolant. That means LOCA, loss of coolant accident. So we already studied four main functions. First one is it maintains reactor coolant chemistry, that means reactivity. The second one is it controls reactor coolant volume, and the third one is it purifies reactor coolant, and the fourth one is it provides high pressure injection. Now we are going to discussing about CVCS working in each stages. When it is in the startup phase, when it is in the during normal operation, when it is in the reactor shutdown phase. When it is in the startup phase, when the reactor is in the startup phase, CVCS ensures the reactor coolant system is properly managed before reaching operational conditions. When it is in the normal operation, CVCS continuously regulates and monitors the conditions of the coolant to ensure the reactor operates safely and efficiently. And in the case of shutdown reactor, the CVCS plays an essential role in the managing the transition to safe, stable and cool condition while ensuring the system remains within the safety limits. These are the three stages of the CVCS. Okay, now we can consider a scenario. If there is any malfunction happens in the CVCS during the normal operation, what will happen? What is the safety requirement? How we can rectify this one? We are saying an incident. If there is if a malfunction occurs in the CVCS, specifically in the letdown line where coolant is withdrawn from primary loop to the control reactor's chemistry. A failure in the letdown valve, it causes an unintended increase in the pressure of the reactor coolant system. This results loss of coolant. We already discussed about loss of coolant, that means LOCA, and inability to properly control the coolant volume. We already know it is affecting the CVCS controlling the volume also. This results in the loss of coolant, inability proper control of coolant volume, which is vital for heat removal and the reactor safe operation. Additionally, the boric concentration in the coolant, which is essential for controlling reactivity. The first function was controlling the chemistry. That means boric acid concentration. Because if there is any happened boric acid concentration in the coolant, it is affecting the reactivity. So it starts to fall due to malfunction. So reactivity will affect in the reactor. This causes a potential imbalance in the reactivity control. If there is any happen in the reactivity, it will imbalanced, increasing the risk of reactivity escalation if it is not promptly addressed. Then what is the solution? The first solution is immediate shutdown. That means SCRAM. What is SCRAM? SCRAM means it is a rapid emergency shutdown of a nuclear reactor. It is designed to immediately stop the fission chain reaction by fully inserting the control rods in the reactor core. This prevents further heat generation and reduces the risk of overheating, especially during the normal or accident condition like LOCA or any unexpected power surge. And the next option is isolation of affected system. The affected part of the CVCS, including letdown line or any associated valves or pumps, need to be isolated by manually or isolation valves. This will also stop any additional loss of coolant from the reactor and contains the problem, giving operators time to assess the situation. Now we got an idea about the CVCS. These are the what is CVCS, what it differs from the other system, and these are the functions. And we already learned if any malfunction is happened the CVCS, what it affects the reactor, and these all are the things about the CVCS. Okay, thank you for watching my video.